In this video, I will explain you classification of material into conductors, semiconductors and insulators based on the energy level. Okay. I will take the example of silicon atom. This is silicon crystal. Now each silicon will be having 4 electrons in the outermost orbit, and now this 4 electron would be shared with nearby 4 silicon atoms, and it would also get 1 electron for sharing from each silicon atom. Now this silicon gives 1 electron for sharing, this silicon gives 1 electron for sharing, this gives 1 electron for sharing, this silicon gives 1 electron for sharing, and this silicon atom has 4 electron in the outermost orbit. Now what is the valency? 8 is the valency. 8 number of valence electrons are there with each silicon atom. Similarly, this would also have 8, this would also have 8 electron, this would also have 8 electron in the outermost orbit. Okay. Now these electrons in the valence orbit possess certain amount of energy, and this energy we will plot on a graph. Now this is the energy. Okay. So these energies, when we are plotting on the graph, these are called as valence energy band. So with semiconductors, these are for insulators. With semiconductors, these are the energy of valence electron of different atoms. So these are the energy possessed by valence electron of different silicon atoms. Now these electrons are in pairing condition or are in bonding condition. They are shared with other electrons to form a valence bond. Okay. So we have electrons here. So these electrons are just representation of valence electron of different silicon atom. Okay. Now when we are increasing temperature, what will happen? The electron will get sufficient energy, and one electron, not only one electron, from different position, electron will come out, and this will become free electron. Now these electrons has got higher energy because they are released when the crystal is given with additional amount or with higher thermal energy. Now this electron will come out only when its energy is increased. It got sufficient energy to come out of its lattice point. Okay, now these electrons are free electron. This can contribute towards conduction. Okay, as it is having higher energy, and as these electrons are contributing in conduction, we would map these energies at a different place, and these are called as conduction band. I would repeat, what is conduction band? Electron from valence band would jump into conduction band. Now let's say 4 electrons are jumped. What is the reason? This electron has got higher energy. How did they got higher energy? With rise of temperature. So I am heating it. Electrons from valence band, let's say this electron is at this position. Now this electron has got higher energy. This has jumped to conduction band. Now conduction band is nothing but energy possessed by electrons in free condition. Okay, these are free electron, or I can say that energy possessed by free electrons. So these electrons are not bonded to any atom. These are free to move. How this would be free to move? When I am applying a electric field. So let's say I am applying a positive potential here and a negative potential here. Now this electron can come here, but this electron cannot come because they are in bonding condition, they are in sharing condition. Okay, so this cannot come, this can come with electric field. Okay, now when they come out of this position, see, net charge should not change. Charges can neither be created nor be destroyed. Now one electron has came here. Initially what was the net charge? Net charge was 0. Clear? It is neutral. Total number of proton and total number of electron was equal with all the silicon in crystalline condition when they are with this atomic structure. This has 0 net charge, 0 net charge, 0 net charge. Whatever electron it is having in outermost orbit and innermost orbit, together whatever the number it is, it would have equal number in the nucleus equal number of proton in the nucleus, making net charge is equal to 0. Now when one electron comes out, this has got negative charge. Now what is the net charge of this atom? That is positive. Now this positive can be represented here. These are called as hole. And the charge, this is just a seed. Okay. Now a person was there and its charge was negative. Now when the person goes out from the seed, this has become positive because initially net charge was 0. Okay. Now this person has gone out and his charge is negative, which means the seed was initially having a positive charge. Now when the person come back to its position, negative charge is loaded to this seed and negative plus positive is a net charge of 0. Okay. Now listen. See, when electrons are being jumped from this valence band, at that place we will have a seed created, that is hole. So I will represent this in solid colors. These are electrons. Okay. Now this electron has jumped to conduction band, so there will be one hole. Okay. The solid dots are nothing but electrons. Now these electrons are being jumped from valence band. Now when they were in the valence band, their energy was less. Okay, now they have jumped to conduction band, their energy is more, and from where they jumped, at that position it returns a positive charge, and these are called as hole. Now what would be the duty of this hole? Now this hole is having a positive charge. This can attract a nearby electron. Now what will happen? This electron will come and takes this position. Now again the net charge becomes 0, but this has become positively charged. Now this hole sees an electron at this position. Now this will attract this electron. Electron takes this seed, making it neutral, but this will become positive. It's a hole. Okay. Now it sees an electron here, and this electron are being jumped to this position, and this become neutral. This is filled now. A person occupied this position. This becomes hole. Okay. So here holes would be in transport, or they will also be moving from one position to another position, and electron will also be moving from one position to another position. Now in the coming lectures I would say that here the energy is due to the combined effect of movement of electron and movement of hole. But anyway, you have seen that a positively charged hole is also moving in semiconductors, and that will also contribute towards conduction because that carries a charge, that is movement of positive charge. That is nothing but movement of hole. Okay. So these are semiconductors. Now in semiconductors, this electron can easily jump from this position to this position because the energy gap is less. Now I will explain what is energy gap. Energy gap is nothing but the energy difference in between conduction band and valence band. Okay. Now only if electrons are there in the conduction band, that can contribute towards conduction. Okay. In the case of insulators, electrons would be in the valence band, and the energy gap is more than 3 electron volt. Now for this electron to jump from this position to this position, it needs very high amount of energy. For each electron it requires 3 electron volt. Now you may ask, 3 electron volt is a small amount of energy, right? Why can't we give it? See, if you are taking 1 meter cube of box, that will carry 10 power 29 electrons. Okay, now for each electron, this would carry 10 power 29 electron, which means to make an insulator to conductor, what we have to do is, with each electron from 10 power 29 electrons available in 1 meter cube box should be provided with 3 electron volt. Now if you are giving such high amount of energy to a material, by that time that would be broken down. You know, when we are raising the temperature of an insulator, so for example this is plastic, when we are raising it to, you know, just by 100 degrees Celsius, this would be melting down. So at such high temperature this cannot withstand, okay, or it is very difficult to raise the temperature of an insulator to such a high value so that each and every electron or a lot of electron which is sufficient to contribute towards conduction would be generated through thermal excitation or jumping from valence band to conduction band. Okay, so here energy gap is greater than 3 electron volt, which is practically difficult to achieve. So when the energy gap is higher, this electron won't jump from valence band to conduction band, and only in conduction band when the electrons are present, that can only contribute towards conduction. Okay, so conduction is not possible with insulators. With semiconductors it is possible because their energy gap is less than 3 electron volt. So on rising the temperature, lot of electron would get higher energy so that this would jump from its position to valence to conduction band, and when now the electrons are in the conduction band, they can contribute towards conduction. At the same time there would be holes created here. Okay, in the case of conductors, the thing is, the red color lanes are conduction band, the black color lanes are valence band. Now these valence band and conduction band is overlapping, which means with no rise in temperature, at the current situations, at the current circumstances, there are a lot of free electron which are already, there are a lot of valence electron which are already available in conductors ready to contribute towards conduction. See, now let's say there are 4 electrons at this position in valence band. Now these 4 electrons are also ready to contribute towards conduction. Why? Their energy level is matching with the valence band. So these 4 electrons can contribute towards conduction. Now if it is having 16 electron, these 16 electron, they are in valence band, they are in bonding condition, but whenever we are supplying a potential difference or electric field, they can contribute towards conduction because they already possess energy which is equal to the energy level of conduction band. So here valence band and conduction band are overlapping. Okay, very important. I would conclude everything in a minute. Okay, so here valence band and conduction band are overlapping. Here valence band, this one is valence band VB and this is conduction band CB. Now here valence band and conduction band are kept at an energy gap of less than 3 electron volt. So it is possible for electron from valence band to jump into conduction band and to contribute towards conduction. But the energy gap is there, it is less, only on rising temperature it is possible. Now here in this case of insulators, valence band and conduction band at very far distance away from each other. Now on rising temperature, that energy won't be sufficient for the electrons in valence condition in the valence band to jump into conduction band because this much amount of energy is required. This is the energy gap. Only when this energy is supplied for each electron, then only it would jump from valence band to conduction band. It is practically very difficult to achieve. So this would behave as insulators and as conductors. At lower temperature insulators, it has no, whenever we are decreasing the temperature, this electron would come back to its seat. Okay, this energy won't be sufficient, so that would come back to its initial condition. There are no electrons in the conduction band, so it is insulator at lower temperature. At higher temperature, when we are increasing temperature, electrons would jump from valence band to conduction band. Now more number of electrons are being generated, that would represent a higher conductivity, so that would behave as conductor. So its behavior will change with respect to temperature. But here already free electrons are available and valence band and conduction band are overlapping, which means many electrons in valence band are already ready to contribute towards conduction because they possess energy that is matching with conduction band. Okay, thank you.